Okay, pre-cal students, in this video we will be looking at the graphs of cosecant and secant functions. So your heading today, if you'll please copy this in your notes, is cosecant and secant graphs, cosecant and secant graphs, and also please include the date in your heading if you would please. Okay? Alright, let's continue on. Because this process is so easy that we're going to learn today, graphing secant and cosecant functions, we're just going to look at one example. Here it is. Now, understand that it's not a short process, but it is easy, okay? So here we go. If you like steps, well, first of all, go ahead and copy this in your notes. Y equals -1 plus 2 cosecant of 2x minus pi. Now, if you like steps, listen to me carefully. Whenever you're graphing secant or cosecant functions, if you want to write this down, you can. The first thing you always want to do is you want to rewrite the problem with its reciprocal function, or reciprocal function. For example, this has cosecant, and the reciprocal function for cosecant is sine. So you would rewrite the problem with sine. Now, pretend the original problem here was secant. Well, if the original problem was secant, then you would rewrite the problem with the reciprocal function, which would be cosine. Okay? So if you like steps, that's the first thing we would do. And so, because this problem is a cosecant problem, the first thing I'm going to do is rewrite it with its reciprocal function, which would be sine. Okay? So we're going to rewrite the problem like it's sine. Now on the very end, when I'm all done, there's going to be a little twist, so you need to pay attention, okay? But for the most part, I think you'll find this pretty simple to follow, okay? Now, even though the original problem is not a sine problem, we're going to go ahead and graph this like it's sine, okay? So, the first thing we do is we check for a shift, a vertical shift. Notice I have a -1 here being added or subtracted to the entire sine expression. So I know I have a vertical shift of -1. So instead of the center of the graph being on the x-axis like we're used to, we're going to go down 1. Okay, and we're going to go ahead and put the center of the graph right there. Now, also in step 1 that we learned in a previous video, we checked the amplitude out. Well, the number right here that I'm circling that's being multiplied times the sine or the cosine is a 2. And that means the amplitude is 2. So from our center dotted line, I'm going to go up to 1, 2. And I'm going to put a dotted line right here. And then from my center dotted line, I will go down to right here. And I will put a dotted line here. Now again, I know the original problem was not a sine function, and I know so far we're graphing it like it is. Bear with me. In the very end, we're going to get the cosecant graph, okay? All right, now next what we've learned to do is we find the period by taking 2 pi and dividing it by b. And of course, b is your x coefficient right here. So I'm going to take 2 pi and divide it by 2, and I will get pi. So I know pi is my period, okay? That's step 2. Now step 3 says to take my entire bx minus c, which is this expression right here, and I'm going to set it equal to 0, and I'm going to solve. So there we go. Bring your pi over and make it a positive pi. Now divide both sides by 2, and you'll get 1/2 pi, or pi over 2. So that's going to be the x value of my first key point. So with my calculator, I'm going to go ahead and type into my calculator -1 plus 2 sine, and then it's 2x. So I'm going to put 2 times pi divided by 2, and then minus pi, and hit enter. Now make sure you're in radians, but if you did all that correctly, you will get -1 out for your y. So I know that I'm over 1/2 pi, and I'm down -1, which is right here. That's perfect, okay? Now, next, It's in my steps that I learned the other day for graphing a sine function. And again, I know that I know the original problem was cosecant. I understand that, okay? But just bear with me, and I'll show you in the very end what to do. Now, what we learned to do next was to take your value from the second step, which was pi, your period, and you divide it by 4, okay? And then you're going to add that to this value right here. So if I'm at a half a pi and I add a fourth, I know then I'm going to be at 3/4 pi, or in other words, 3 pi over 4. So now with my calculator, I'm going to go back up here and I'm going to type into my calculator -1 plus 2 sine 2 times, and then for pi over 2, for x, I'm going to put 3 pi over 4, okay? And then hit enter. If you do that correctly, you will get out a 1 right here. So now, I know that I went from a half a pi over to 3/4 of a pi right here, and I know I go up 1. Now, if you remember correctly, what I taught you to do was you continue to go over the same increments and just go up, down, middle, so on and so forth. So from here to a fourth is here, and then to the middle, and then go over a fourth and down, and then go over a fourth, back to the middle line, then over a fourth, back to the top dotted line, then over a fourth, back to the middle. And now we'll go the other way. From here I go over a fourth, then down to the bottom dotted line, over a fourth, up to the middle, over a fourth, back up to the top, over a fourth, down to the middle dotted line, over a fourth, down to the bottom, over a fourth, back up to the middle, over a fourth, up to the top, and I think that's sufficient. Now, you're used to doing this. You're used to drawing the actual sine graph, and I know I'm not doing a very good job, but don't do that, okay? Please don't do that, because remember, the original problem was not sine, okay? Remember that? The original problem, let's look up here, the original problem right here was cosecant. So we've done all this sine to kind of help us with the graph. Now watch. What you do is you draw a dotted sine graph. So we're going to draw a dotted sine graph, okay? Now I hope you're taking really good notes on this. I never said it was short. What I said is the process is easy. We don't need to do a lot of these, because really, can you not tell what we're doing here? It's really just reviewing graphing a sine or a cosine function, except for a very interesting twist at the end, okay? So there we go. That's sufficient. That'll do for now. There we go. Now, everything we did there is totally review. Whatever your function is here, you write the reciprocal function. So if it's secant, you use cosine. If it's cosecant, you use sine, and you draw the graph just like you learned the other day, only you put a dotted graph. Now, here's why you put a dotted graph. Please listen to me carefully. And I hope you have enough room in your notes to do this. Now watch this carefully. The actual secant, the actual cosecant graph that you want is right here. Do you see this? Look at all of your points on your middle dotted line. Let me say that again. Look at all of your points on your middle dotted line. Where those points are, I'm going to change colors here. Where those points are, you're going to draw vertical asymptotes. That means vertical dotted boundaries. Okay? So everywhere you see a point on the middle dotted line, you're going to draw a dotted vertical asymptote. And if you don't remember what a vertical asymptote is from Algebra 2, it's a line that the graph does not cross. Okay? And again, how many of these do and how far your graph goes is kind of subject to one's own decision on that, but just make sure you're thorough, okay? Now, here's the actual graph. We did all of that work to just get this. You know what the secant graph is? The secant graph, see this low point on the bottom dotted line? It's a parabola that falls between your two vertical asymptotes. Now go to this high point right here. Well, it's the same thing. Now go to this bottom point. Okay, now go to your next high point on the your top dotted line. And I guess you can just go across the top. All of your points on your top dotted line are going to be, I'm not sure why I'm making them dotted, they're parabolas. Okay? So all of these points on the top dotted line are parabolas. All of these points on the bottom dotted line are also parabolas, same thing. So, if you want to know the truth of the matter, the actual graph is just the blue parabolas. That's it. That is the secant graph. So everything else, notice the red here is in dotted lines. Notice the green is in dotted lines. Notice the black vertical asymptotes are in dotted lines. If you really, and you don't have to do this on a test or a quiz, but if you really wanted to see just the secant graph, or excuse me, the cosecant graph, then I guess we would erase all of these dotted lines, and the blue leftover part would be the actual cosecant graph. And as you can see, I'm taking a little bit of time to do this, but I really want to make sure you understand what the actual cosecant graph is, okay? All these dotted lines were just boundaries, and that's it, nothing else. And I know I'm accidentally erasing some of the blue, but I'm not meaning to, okay? And I'm probably being long-winded and boring, but I want to make sure you understand this, okay? That's good enough. So those blue parabolas that you're seeing, that's the graph of the cosecant. So let's quickly review, and then we'll be finished, okay? Whenever you're graphing a cosecant or secant graph, the first thing you do is you rewrite the function with its reciprocal function. In this case, the reciprocal of cosine is sine. Then after you've done all the graphing of the sine, and make sure you do everything in dotted, okay, in dots, then the middle dotted line points are your vertical asymptotes. The points in your top dotted line are your parabolas going upward. Your points in your bottom dotted line are your parabolas opening downward. Okay? And there it is. These blue parabolas are the actual graph of this cosecant function. So I didn't say it was short. I did say it was a simple procedure. I believe is what I said. It's easy. It is easy. It's not difficult. If you understood how to graph sine and cosine functions, then you're finding this very easy. But it is long. It is going to take time. But that is how you graph these. Okay? All right. If you have any questions, don't hesitate to call or email.